Thank you, Stein. So indeed, we had this very interesting session on Tuesday, sorry, for which Johannes and myself had the pleasure to welcome a few presentations, which I will summarize before coming to the main discussion points. So there was indeed an outstanding dust event which occurred over Europe in March 22, just a few weeks ago. And this event was outstanding in several ways, and I'm pretty sure several of you have heard about this specific event, in particular through the media. And one of the striking images that was recorded several places in Europe is the really important deposition of desert dust which occurred. I think this picture is from Spain, but similar images were also recorded further north. From the in situ data, such as reported to EEA in real time, we could see records like this one, recorded in south of Spain, in Almeria, where you have a very sharp increase reaching up to the saturation levels of the reference air quality stations. So those are not sensors, but the reference air quality stations were actually saturating up to 1,000 microgram per cubic meter. So it's really huge. And we could also look in the various CAMS products how important was that episode. So here I'm just showing two slides, two figures for illustration. On the bottom right, you have a long-term time series from the CAMS global reanalysis starting in 2003. This is looking at AOD over Spain, the daily mean AOD over Spain, when you have this almost 20 years record, with that specific day really standing out from anything that has been seen in Spain over the past 20 years. So it's really one of the most important, or maybe the most important episode that was recorded as seen in the reanalysis of the global model. So it's also, here is another view from a regional model, IMEP in this case. As part of the policy service, IMEP is also providing on the website, on the policy website, the actual chemical composition of a particulate matter. And if you look at what happened over the first 6 months of 2022, for this specific location, I think it's Madrid, you have really very strong accidents which occurred in March this year. And clearly, the yellow part, so the dust load, is the main responsible for this episode. So all this is good motivations to actually investigate further the event, and also an opportunity for us as a CAMS community to reflect on the tools we have and their strengths and weaknesses to actually document such cases. So we first had a presentation from the CAMS Policy Service. It was actually Metno, Michael Schulz from Metno giving this presentation to present a few highlights of an episode report which was already prepared and is already on the website of the Policy Service. So you can refer to a full report which is already available. There were a few highlights such as what I presented before in terms of chemical composition, but here I really wanted to take one focus in the importance of the vertical stratification. So the dust episode which occurred in March was surprising for some people, because we had very large concentration over Spain, but not so much over France, even though there were a lot of reports of strong deposition, the images of the car I was showing before. So this may be obvious, I think, for most people in the room, that the dust plume can be advected in altitude, but for a few of the users of the CAMS service, it's not obvious at all, and it's in particular the case for policy users. And this is clearly illustrated in that one picture, when you see the deposition over mountainous area, which is actually not necessarily reaching the top highest levels. So it was a very nice opportunity for us to look back in the models. So this is a few screenshots of the CAMS regional ensemble at various levels. So if the label is perhaps too small, but on the left it's at the surface, 1,000 meters and 3,000 meters of altitude. And you realize that even in Spain, the concentrations are very high at the surface. It's not the case typically over France, whereas in altitude, we clearly see the plume in the ensemble forecast. And so this is an opportunity to showcase what we can understand from the models to explain this picture, which is seen from the in situ data. But it's also an opportunity for us to better connect with the research community, providing more sophisticated measurements, namely this cellometer data, which are becoming now available on real time in the eProfile database, where you can see that, for example, in Madrid, you have a very high load at the surface, and if you go to Switzerland, the plume is in altitude. So all this is things that we expect, but it's always nice to actually be able to take stock of this, to convey a clear message to the users, to also explain them how CAMS products can be used. Of course, such dust episodes are also an opportunity for us to reflect on the quality of the modeling system and how we should investigate further. So we had a presentation from given by Oriol Jorba and also prepared with Sarah Bassat from BSC, taking stock of the work undertaken in the CAMS 61 project, which finished last year. There was a specific work package looking at regional model development and evaluation, where BSC came up with this innovative way to quantify the ensemble of regional models, specifically for dust. And in doing that, of course, one would like to look for actual dust measurements, but it's very difficult to get access to those, and there are few stations doing the PM composition analysis. But you can also use the hundreds of PM automated stations and look at the ratio PM2.5 divided by PM10, and look. So here you will have the results in the observation and in various models, so on the top global models, and I just picked for the illustration 3 regional models. And what you will realize is that there is a diversity in the performances of the model to capture well this ratio PM2.5 divided by PM10. So clearly a scope for further improvement. Both on an annual basis, but you can also look at specific episodes. So that's the type of results also which were illustrated for modelers to better understand their capacity to actually capture this dust plume. Another illustration was given by BSC, taking inspiration of the work they do as part of the WMO Sun and Dust Storm event. It's actually quite nice also to look at probabilistic risk of exceedances. It's something we don't do yet in CAMS, but maybe an innovation we should look for in the future. Another illustration, I need to go very quick, on the benefit of using a coupling between atmospheric composition and numerical weather prediction. So this was work presented by ECMWF on the basis of the global model. This event in March 22 was actually an unprecedented case where the benefit for the weather forecast could be demonstrated for a dust episode in Europe. There were previous proof of such benefits, but for more biomass burning and not really in Europe. So there was a clear improvement of the scores in predicting the weather when the prognostic aerosols of the dust plume were taken into account. Sorry, I'm really skimming through all this, but I guess the slides will be available. I want to spend a bit more time to highlight the main general discussion points. Of course, this was a cross session between regional and global models, so really good opportunity to discuss the way we handle boundary conditions in the regional models. It is the fact that the global and the regional models have different aerosol formulation and different size bins. In the regional models, we can have between 2 to 10 bins. Those needs to be mapped on the 3 bins of the global models. So the regional models took different hypotheses to do this mapping, and this is really an opportunity to take stock of the diversity of the regional ensemble. There is scope to do an in-depth review of how this matching is done, but there is also scope to actually analyze the spatial correlation at various levels of the regional ensemble, in particular to look at the importance of the granulometry of PM, but also the various skill of the models depending on the choice they make in terms of representing the advection. And that's really something unique that we have in the regional ensemble, different model formulation, and this is also a potential scope for further research. Then we also discuss more operational concern, how we handle the changes in the IFS model when we do model upgrade also in the regional production. So we discussed a further communication streams that could be improved in the future. And just to finish, a few other discussion points which were briefly mentioned, but I really wanted to recall here. The fact that there is ongoing research also to improve the emission of dust by looking at the actual mineralogy of the dust in order to improve the way we know emission sources. Also the fact that some regional models are producing dust emissions inside the regional domain. So this is also a scope for collaboration. An important point, we just discussed evaluation. Something we don't evaluate yet in CAMS is a total budget, atmospheric budget. So it would be interesting to also report the emissions in the models, to also report the deposition, to look at what is the overall load of the modeling domain, besides just looking at atmospheric concentrations. And of course, we also discussed the very rational why we are concerned with such events. The fact that desert dust have a very strong impact on health, but also on ecosystem through the deposition of nutrients in particular for ocean areas, operational impact for the solar industry, obviously, and also a very clear application for policy making in Europe, because exceedances are reported by individual countries and the natural fraction can also be discounted. Sorry for going very quickly, but I'm done.
Thank you, Augustin. Thank you, Augustin. Time for one question. Federico?
The question is, hi Augustin, is about the analysis of the event. This has been an event that was very persistent with a very long range transport, with observation of the same dust that arrived until, let's say, Siberia and potentially Asia. Have you evaluated in the model how the whole transport and the global circulation was assimilated in that case?
You're saying that for that one case, there was documented evidence of transport up to Siberia?
Yeah.
Yes. No. So I'm sorry. I'm not aware of such analysis for that case. But of course, the data is still there, and we could definitely look at it. Yes.
Leonore?
Of course, I'm talking about dust. I would have liked very much to be in that session, and it is in the link to the policy, because we are always discussing the part of making use of the data from Copernicus to be able to say something about the exceedances. And by now we are still having a challenge, because we have the global model, the regional model. It's good to say that there is an intrusion, but the quantification is still a problem. And this is the part that I think in the next policy workshop we'll have to discuss this. And we need to put some more of that evidence of how we can quantify it really, and what are the constraints on the quantification. So what are your views on how can we proceed with the quantification? Will at all can we constrain the information so that it can be used for policy?
I guess that would be too long for the chair to let me elaborate on this, but it's like you said, it's a very valid point. There are a few countries who have already their methodologies to actually do this discounting, including in a quantitative ways. Whether they use models or measurement, there are a variety of approaches, and it's an excellent point of discussion for a forthcoming workshop, policy user workshop of CAMS.
Okay. Thank you.
Johannes,
yeah.
Just a quick remark on Frédéric's comment. So what we noticed that we could predict the dust plume already several days ahead, and I think this is a sign that we captured it really well, also from the dynamical point of view.